Hello students, welcome all of you. In this video, I Abhay Kumar going to discuss a very important topic in thermodynamics, which is absolute scale of temperature or Kelvin's absolute thermodynamic scale of temperature for B.Sc Part 1 physics courses, that is physics honors, physics subsidiary and physics general courses. In lecture number 8 of thermodynamics, Kelvin devised a temperature scale which is independent of the property of any particular substance. For example, working substance, gas of a reversible heat engine or Carnot's heat engine, and that temperature scale is known as absolute scale of temperature or Kelvin's absolute thermodynamic scale of temperature. Absolute scale of temperature is based on the Carnot's theorem. केल्विन ने एक टेम्परेचर स्केल को दिया जो किसी रिवर्सिबल हीट इंजन और कार्नोट हीट इंजन के वर्किंग सब्सटेंस गैस के किसी प्रॉपर्टी पर डिपेंड नहीं करता है, बट टू टेम्परेचर लिमिट्स, दैट इज टेम्परेचर ऑफ द हीट सोर्स एंड टेम्परेचर ऑफ द सिंक, दैट इज T1 के एंड T2 के रेस्पेक्टिवली, पर डिपेंड करता है, जिनके बीच कोई रिवर्सिबल हीट इंजन वर्क करता है. एब्सोल्यूट स्केल ऑफ टेम्परेचर कार्नोट थ्योरम पर बेस्ड है. अकॉर्डिंग टू कार्नोट थ्योरम, द एफिशिएंसी ऑफ ऑल रिवर्सिबल हीट इंजन्स do not depend on the nature or material of the or working substance gas of the reversible heat engines. Rather, it depends, that is efficiency of a reversible heat engine depends between two temperature limits, that is temperature of the source T1K and temperature of the sink T2K, between which that reversible heat engine works. Hence, we can say that absolute scale of temperature is based on the Carnot's theorem. Now we will define absolute scale of temperature or Kelvin's scale of temperature mathematically. Suppose a reversible heat engine works between two temperature limits, say temperatures θ1 and θ2, where θ is the temperature of the heat source and θ2 is the temperature of the sink. Let Q1 be the heat absorbed by the working substance or gas of the reversible heat engine at temperature θ1, while Q2 be the amount of heat rejected to the sink at temperature θ2. So we can write efficiency of that reversible heat engine, symbol is eta, is equals to 1 minus Q2 upon Q1. It is the formula of efficiency of a reversible heat engine, that is eta, symbol of efficiency, the symbol of efficiency is eta. Eta is equal to 1 minus Q2 by Q1. Q1 is the amount of heat taken by the working substance or gas of the heat engine from the heat source at temperature θ1. Say in place of T1, the temperature is we have taken θ1, and Q2 is the amount of heat rejected to the sink, that is colder body, at temperature θ2 in place of temperature capital T2K. So efficiency of that reversible heat engine, eta equals to 1 minus Q2 upon Q1, and it is the function of F, say it is function of temperature θ1 comma theta 2 under bracket, or we can write q2 by q1, q2 by q1, sorry, q1 q2 by q1, we can write q2 by q1 as 1 minus f theta 1 minus theta 1 comma theta 2. Therefore q1 by q2 we can write as 1 upon 1 minus f theta 1 function of theta 1 temperatures, two temperatures theta 1 and theta 2. तो इफिशियंसी ऑफ हीट इंजन या फंक्शन है टू टेम्परेचर्स थीटा 1 that is temperature of the heat source and other temperature theta 2 temperature of the sink, temperature of the sink. So eta equals to 1 minus q2 upon q1. This is the formula of efficiency of a heat engine, and it is equal to function of efficiency is the function of theta 1 theta 2. So q1 upon q2 we can write 1 upon 1 minus f theta 1 comma theta 2, and it is say it 1 by 1 minus f theta 1 theta 2, say it capital F, another function of temperatures, two temperatures theta 1 and theta 2, and let it is equation number 1. So for a reversible heat engine working between two temperature limits theta 1 and theta 2, q1 by q2 equals to, q1 is the amount of heat taken from the heat source at temperature theta 1, and q2 is the temperature of q2 is the amount of heat rejected to the sink at temperature theta 2. Now suppose another reversible heat engine working between two temperature limits theta 2 and theta 3, we can write q2 by q3 as the function of f theta 2 and theta 3. So similarly we have for another reversible heat engine working between two temperature limits theta 2 and theta 3, that is q2 is the amount of heat taken from the heat source at temperature theta 2, and q3 is the amount of heat rejected to the sink at temperature theta 3. q2 अमाउंट ऑफ हीट है जो कि हीट सोर्स से रिवर्सिबल हीट इंजन द्वारा एब्जॉर्ब किया गया, while q3 is the heat rejected to the sink, that is colder body at temperature theta 3. So we can write for that reversible heat engine q2 upon q3 equals to capital F, where capital F is the another function. Capital F theta 1 theta 2 we have written in place of 1 upon 1 minus a small f theta 1 comma theta 2. So q2 upon q3 equals to f function of temperatures theta 2 theta 3, say it is equation number 2. And for a third reversible heat engine which works between temperature limits theta 1 and theta 3, that is suppose q1 be the amount of heat taken from the heat source at temperature theta 1, while q3 is the amount of heat rejected to the colder body sink at temperature theta 3. अब एक थर्ड रिवर्सिबल हीट इंजन को सपोज किया जाए जो कि टू टेम्परेचर लिमिट्स थीटा 1 एंड थीटा 2 के बीच वर्क करता है. q1 अमाउंट ऑफ हीट है जो उस रिवर्सिबल हीट इंजन द्वारा, थर्ड रिवर्सिबल हीट इंजन द्वारा हीट सोर्स से ऑब्टेन किया जाता है, एब्जॉर्ब किया जाता है, जबकि q3 अमाउंट ऑफ हीट है जो थीटा 3 टेम्परेचर पर किसी कोल्डर बॉडी दैट इज सिंक को रिजेक्ट किया जाता है, सप्लाई किया जाता है. देन वी कैन राइट फॉर द थर्ड रिवर्सिबल हीट इंजन q1 अपॉन q3 इक्वल्स टू फंक्शन ऑफ कैपिटल F theta 1 comma theta 3, and say it is equation number 3. Now multiplying equation 1 and 2. Now multiplying equation 1 and 2, we can write q1 left hand side is Q1 upon Q2. Left hand side of LHS of equation 1 is Q1 upon Q2. LHS of equation 2 is Q2 upon Q3. Now multiplying LHS of both equations, we have Q1 upon Q2 multiplied by Q2 upon Q3, and RHS of equation 1 is F theta 1 theta 2. So write F capital F theta 1 under bracket theta 1 theta 2 multiplied by, now RHS of equation 2 is F theta 2 theta 3. So F theta 1 in RHS, F theta capital F under bracket theta 1 theta 2 bracket closed multiplied by capital F theta 2 theta 3, and Q2 in LHS, Q2 will cancel out, Q2 and Q2 will cancel out in the numerator and denominator. तो LHS में न्यूमरेटर में Q2 एंड डिनोमिनेटर में भी Q2 है, वह कैंसिल हो जाएगा. देयरफॉर वी कैन राइट इट एज LHS बिकम्स Q1 अपॉन Q3 इक्वल्स टू F थीटा 1 कॉमा थीटा 2 मल्टीप्लाइड बाई F अंडर ब्रैकेट कैपिटल F अंडर ब्रैकेट थीटा 2 कॉमा थीटा 3 ब्रैकेट क्लोज्ड. Suppose it is equation number 4. Now comparing equations 3 and 4. In both equations, Q1 by Q3 is present in LHS. That is, Q1 by Q3 is present in LHS of equation 3 and also in RHS of equation 4, which we have just obtained. So RHS of both equations, that is equation 3 and equation 4, will also be equal. Therefore, we have F RHS of equation 3 is F theta 1 capital F theta 1 capital F under bracket theta 1 comma theta 3 bracket closed equals to F theta 1 comma theta 2 multiplied by capital F theta 2 under bracket theta 2 comma theta 3. Therefore, we can obtain F capital F, which is the function of temperatures theta 1 and theta 2. So capital F under bracket theta 1 theta 2 equals to F capital F theta 1 comma theta 3 under bracket upon F F theta 2 comma theta 3 capital F under bracket theta 2 theta 3, and it is equation number 5. Since LHS of equation 5 is independent of temperature theta 3 while RHS contains theta 3, so equation 5 will be satisfied only if the function in LHS, function capital F in LHS must be such that theta 3 cancels out in RHS. चूंकि इक्वेशन 5 के LHS में टेम्परेचर थीटा 3 प्रेजेंट नहीं है, जबकि RHS में टेम्परेचर थीटा 3 प्रेजेंट है, तो इक्वेशन 5 तभी सेटिस्फाई होगा जब इक्वेशन 5 का LHS का फंक्शन कैपिटल F वैसा होगा जब RHS में टेम्परेचर्स थीटा 3 न्यूमरेटर एंड डिनोमिनेटर में कैंसिल हो जाएगा. नाउ इक्वेशन 5 कैन बी रिटन एज कैपिटल F which is the function of temperatures theta 1 and theta 2. So capital F under bracket theta 1 comma theta 2 equals to phi. Now phi is the function of now phi is a new function which is the function of theta 1 only in the numerator. So phi under bracket theta 1 upon phi theta 2. In the denominator we have taken phi, which is a new function. Phi is a new function, and in RHS it is the function of only theta 2, while in the numerator phi is the function of temperature theta 1. So let it is equation number 6. So we have equation 6 is capital F under bracket theta 1 comma theta 2 bracket closed equals to phi theta 1 phi under bracket theta 1 upon phi under bracket theta 2. Similarly, for other two reversible heat engines, we can write similarly for two other reversible heat engines, we can write f function of theta 2 theta 3, that is f under bracket theta 2 comma theta 3 equals to phi theta 2 phi under bracket theta 2 upon phi under bracket theta 3, and suppose it is equation number 7, and also for the third reversible heat engine which works between two temperatures theta 1 and theta 3, we can write f under bracket theta 1 theta 3 equals to phi is the function of temperature theta 1 upon phi temperature theta 3. So for the third reversible heat engine, we can write capital F under bracket theta 1 comma theta 3 equals to phi under bracket theta 1 upon phi under bracket theta 3, where phi is the new function in place of the function capital F, and it is equation number 8. Now, using equation 1, LHS of equation 6, that is capital F under bracket theta 1 comma theta 2 can be written as Q1 upon Q2. In place of F theta 1 theta 2, we can write Q1 upon Q2 equals to RHS of equation 6 is phi theta 1 upon phi theta 2. Equation 6 का RHS phi theta 1 upon phi theta 2, and equation 1 में 1 के हेल्प से F थीटा 1 F अंडर ब्रैकेट थीटा 1 कॉमा थीटा 2 के जगह पर रिप्लेस किया गया Q1 बाई Q2, जो कि इक्वेशन 1 के LHS में प्रेजेंट है. एंड सपोज इट इज इक्वेशन नंबर 9. नाउ RHS of equation 9 represents the ratio of two Kelvin temperatures phi theta 1 and phi theta 2, and it can be written as the ratio of tau 1 upon tau 2, that is tau 1 and tau 2, that is phi. In place of phi theta 1, we can write the Kelvin temperature tau 1, and in place of phi theta 2, we can write the Kelvin temperature tau 2. So RHS of equation 9, that is equation 9, can be written as phi 1 upon phi 2. Therefore, phi 1 upon phi 2 equals to tau 1 upon tau 2. And from this relation, that is equation 10 defines absolute scale of temperature. Write down equation 10. This equation defines the absolute scale of temperature. Where tau 1 and tau 2 are two Kelvin temperatures in absolute temperature scale, and these two temperatures, that is tau 1 upon tau 2, is equal to the ratio of Q1 upon Q2, that is ratio of Q1 upon Q2, that is heat taken, that is the ratio of heat taken from the source by the working substance of the reversible heat engine to the at temperature tau 1, and Q2 is the amount of heat rejected to the sink by the working substance of the reversible heat engine at temperature tau 2. Now, zero of this temperature scale, that is absolute temperature scale, is absolute zero temperature or negative or any negative temperature is possible on the absolute scale temperature. So since efficiency of a reversible heat engine in absolute temperature scale, yes, or absolute scale of temperature can be written as eta is equal to 1 minus Q2 upon Q1. We have to discuss absolute zero or zero temperature of absolute temperature, absolute scale of temperature, absolute zero temperature in absolute zero temperature in absolute zero temperature at absolute in absolute scale of temperature. So efficiency of a reversible heat engine at the absolute scale of temperature is eta equals to 1 minus Q2 by Q1 equals to 1 minus tau 2 upon tau 1. For if tau 2 is equal to 0, that is temperature of the sink in absolute scale temperature is 0, then tau 2 upon tau 1 or Q2 upon Q1, that is tau 2 upon tau 1 or Q2 is equal to Q2 upon Q1 equals to 0. In that case, efficiency of that reversible heat engine will be 1. 1 means 100%. So absolute, we can define absolute zero temperature in absolute scale of temperature is that temperature at that temperature of the sink at which no heat is rejected by the working substance, that is gas of the reversible heat engine to the sink, and total amount of heat Q1 taken from the heat source at temperature tau 1 is directly converted into heat, that is 100% conversion of heat into work. According to, in that case, efficiency of the reversible heat engine will be equals to 1 at temperature tau 2 is equal to 0, Q2 must be equal to 0, amount of heat rejected to the source is 0, then total amount of heat taken by the working substance of a reversible heat engine is directly converted into work without any part of the heat rejected to the sink. And according to Kelvin Planck's statement, the efficiency of a reversible heat engine cannot be 100%. So absolute zero temperature or any negative temperature in absolute scale temperature is not possible. So write down, hence absolute zero temperature or zero temperature less than zero temperature, that is negative temperature less than 0, that is tau 2 is equal to 0 temperature in the, that is negative temperature, less than 0 means negative temperature, that is negative temperature is not possible in the absolute scale of temperature or Kelvin's scale of temperature. और इस पार्ट को एब्सोल्यूट स्केल ऑफ टेम्परेचर के इस पार्ट को कि इज निगेटिव टेम्परेचर और एब्सोल्यूट जीरो टेम्परेचर इज पॉसिबल ऑन एब्सोल्यूट स्केल टेम्परेचर, इसे इस टॉपिक के टेल पार्ट में, इस टॉपिक पर बेस्ड जो यूनिवर्सिटीज एग्जामिनेशंस में क्वेश्चन पूछे जाते हैं थर्मोडायनामिक्स में, तो उसमें टेल पार्ट में इसे पूछा जाता है। टेल पार्ट में एक और टॉपिक पूछा जाता है कि इफ देयर इज आइडेंटिटी ऑफ परफेक्ट गैस टेम्परेचर स्केल एंड एब्सोल्यूट और केल्विन स्केल ऑफ टेम्परेचर। तो क्या परफेक्ट गैस टेम्परेचर स्केल, जिसमें वर्किंग सब्सटेंस में रिवर्सिबल हीट इंजन के वर्किंग सब्सटेंस में परफेक्ट गैस का यूज किया जाता है, तो परफेक्ट गैस टेम्परेचर स्केल और केल्विन स्केल ऑफ टेम्परेचर और एब्सोल्यूट स्केल ऑफ टेम्परेचर क्या आइडेंटिकल है, तो उसे भी इस टॉपिक के एब्सोल्यूट स्केल ऑफ टेम्परेचर के टेल पार्ट में यूनिवर्सिटीज फिजिक्स पेपर्स एग्जामिनेशंस में पूछे जाते हैं। सो राइट डाउन इन लास्ट आइडेंटिटी ऑफ परफेक्ट गैस स्केल टेम्परेचर एंड एब्सोल्यूट स्केल टेम्परेचर। आइडेंटिटी ऑफ परफेक्ट गैस टेम्परेचर scale and Kelvin's scale of temperature or absolute scale of temperature. If an ideal gas is used as a working substance in a reversible heat engine, then efficiency of that reversible heat engine we can write eta equals to 1 minus T2 upon T1. For a perfect gas scale, for a perfect gas temperature scale. And when Kelvin's scale of temperature is used, it is in perfect gas temperature scale. If absolute scale of temperature is used, then efficiency of heat engine is given by eta equals to 1 minus tau 2 upon tau 1. Suppose it is equation number B. When ideal gas or perfect gas is used in a reversible heat engine, that is in perfect gas temperature scale, efficiency of heat engine is 1 minus T2 upon T1. Suppose it is equation number A. And if in absolute scale of temperature or Kelvin's scale of temperature, it is eta equals to 1 minus T2 upon T1. So comparing both equations, we have 1 minus T2 by T1 equals to 1 minus tau 2 upon tau 1, because LHS and RHS of both equations 1 and A and B, efficiency for eta is present. So comparing equations A and B, we have comparing equations A and B, we have 1 minus T2 upon T1 equals to 1 minus tau 2 upon tau 1. 1 and 1 will cancel out in LHS and RHS. So we have T2 upon T1 equals to tau 2 temperature of the sink in absolute temperature scale. Tau 2 is, and tau 1 is the temperature of the heat source in absolute temperature scale. So T2 upon T1 equals to tau 2 upon tau 1. That is the ratio of two temperatures, that is temperature of the sink and temperature of the heat source, that is T2 by T1 in perfect gas temperature scale, is equal to the ratio of two temperatures, that is temperature of the sink in absolute temperature scale and temperature of the source in the absolute temperature scale, both are equal, that is T2 upon T1 equals to tau 2 upon tau 1. So say it is equation C. So we can say that both, that is perfect gas temperature scale and Kelvin's scale of temperature are identical. Now this video is completed. यदि यह वीडियो आप सभी को पसंद आया हो तो इस वीडियो को अधिक से अधिक लाइक करें तथा मेरे यूट्यूब चैनल फिजिक्स क्वांटम क्लासेस को भी अधिक से अधिक सब्सक्राइब करें. थैंक्स ऑल ऑफ यू फॉर वॉचिंग माय यूट्यूब चैनल फिजिक्स क्वांटम क्लासेस.